Hi, everyone. First of all, let me check with you if my presentation is working fine. If anybody could just type in that the slides are the right format, that would be very cool. And yeah, let's start this presentation, which will be about the applications of generative adversarial networks in online business and beyond. And first, let's start about a couple of words about me. So I work as a tech lead and senior machine learning engineer at Tautkutė, Poland. And also currently I'm finishing my PhD studies at the Polish-Japanese Academy of Information Technology. In my free time, I am also AI and recently NFT artist, which is a new trend in blockchain. Now, during my projects at Tautkutė, I've helped many startups build amazing products. Some of the projects that I did involved building a human recognition system in the autonomous cars that were operating in California, as well as food recognition models for smart ovens based in San Francisco, and doing data analytics for smart sensors on smart tires. So there's a lot of smart things, but nowadays more and more technologies and more different industry branches are actually taking advantage of the solutions that AI provides and the automation that can be delivered with various AI tools. And I'm actually helping a lot of different companies to find the areas where they can leverage with that. Now, during my free time, I do something quite different, which is I create generative art with artificial intelligence. So this shows that AI has also new capabilities, not only in business and in the industry, but also in such areas mostly reserved for humans so far, such as arts. Nonetheless, even though the AI is not creating art on itself, it's serving as the new creative tool that is more and more used by artists worldwide. So during this talk today, I will start with explaining briefly what is a generative adversarial network. Then I will present an e-commerce use case where we tackle the problem of multimodal product search and how did we use generative adversarial networks to solve the problem of multimodal search. Then I will mention my projects that I did with using GANs in creative applications. And finally, I'll give you some takeaways for those of you who will be interested in applying GANs in your own solutions. Okay, so let's start with a brief introduction into GANs and what I'm actually doing now. I'm going to publish a poll by asking you a question. Have you ever trained a generative adversarial network before? As I'm interested how many of you actually are familiar with this machine learning architecture. I bet that most of you have heard about the results of these networks, but yeah, from what I see, many of you have never trained GAN before. So yeah, it's good to know your experience here. So hopefully after this presentation, you will also perhaps train your own network and see how can you apply it to your area. So actually, the GANs were introduced not so far ago in 2014, and they have come a tremendous progress in those recent years. Now, when in 2014, the first network that was introduced was able to produce pixelated small images of a resolution similar to 8 by 8 pixels or 24 by 24 pixels. In the upcoming years, the quality has increased dramatically. And nowadays, the most recent architectures produce results that look so realistic that sometimes even for humans, it is quite difficult to judge whether the images were captured by a camera and by a human, or whether they were produced by a generative adversarial network. So all those humans you see in this picture are non-existent humans. All of them were generated with GANs, with style GAN architecture in particular. Now, it is not only working on photographs of human, it is also working on paintings. So here you can see a result of training a generative adversarial network on a set of classical paintings. And they indeed do like coming from Renaissance or some other area in the art history. Going forward, GANs are able to produce results that are from other domains, such as animals. What is interesting is after training such a network, those models are able to interpolate between different instances of categories, such that they produce continuous interpolations between different categories of things. So yeah, going forward, you not only are able to generate artificial humans that don't exist, artificial animals that don't exist, but also we can apply that to a wide range of products. For example, in the e-commerce setting, it has been applied to produce different kinds of garments, different kinds of product items, shoes, and other e-commerce items, so that it can be used as a helpful tool for producing new either ideas for the upcoming products, as well as suggestions to the users and many other applications here. Now, the problem that we wanted to tackle in our application of generative adversarial networks in e-commerce was the problem that many of the users had about having problems finding perfect items. Now, in real life scenarios, it is often happening to the consumers that they might see an item of interest in real life scenario, riding on a subway. I guess today maybe it's happening not so often as before the pandemic, but still the inspiration for different items might come from real life, from the internet, from social media, and not always the links are included, or just simply if you see something on the street, you're just not able to know where it comes from. Of course, there are many engines that try to tackle this project with visual search. The most prominent visual search engine is, of course, Google Image Search, and it works quite well. But the biggest problem with those visual search engines is that they retrieve not the exact results that you're looking for, but just similar looking images. So if you were to search for sneakers from the previous image of a young man riding in a subway, then and upload them to a visual image search engine, then you would probably see similar images of shoes being worn and on some gray background, but definitely the background is not something that we are interested in. We are more interested in the exact model. Now, to facilitate the task of navigating vast resources of product items, there have been some handcrafted solutions recommended by different e-commerce platforms. For example, using many different filters that have a lot of different features. Now, it might help users navigate it a little bit better, but it still poses a huge problem that most of those features have to be crafted manually. And if there is a new feature, the whole data set has to be annotated from scratch. Now, our solution to this problem is multimodal search, which means that user is going to search not only with image, but also with natural language text query. In a nutshell, it would be as combining simple Google search, where you can just type anything you want, with Google image search. And the use cases for those scenarios would be when somebody has an image that is not perfect. So it might be an image taken on the street, but also it might lack some additional features or some additional functionalities. So he might want to change a feature from this image. For example, change a color of the item, or change the material, look for a particular brand, or look for a particular size. There are many different possibilities. And what is good about this approach is that it is not limited to predefined sets of attributes, but the users are able to express their interest in free language. Now, by applying GANs in this multimodal search, what we are able to do is, by taking an image from the user and a free text query from the user, we generate a synthetic image that is then used as a visual search query to search the most similar items in the database. It is still limited to the items that we have in the database, as we want them to buy something that we already have in stock. On the other hand, it also serves as an additional proxy of users' interest. So if we see that users are looking a lot for something that is very different from the products that we have, we might rethink our strategy and produce items that are similar to user intents. Now, let's rewind to how actually GANs work and how is it possible to solve our problem with those models. And can we just use a simple model, or should we apply any modifications to that in order to have a working solution? So actually, the vanilla generative adversarial network works by having two components of discriminator and generator, and it is only able to produce results that are real looking without any other additional attributes. You cannot say, hey, GAN, produce me a blue shoes picture, but it's more like you give GAN a lot of different images that are real, and it tries to imitate those images by producing similar looking results. Now, the first component, generator, does just that, produces synthetic image, but there is also a discriminator component that sees both real images and synthetic images, and then tries to predict which of them are real and which of them are fake. By getting better at finding those fake images, the generator also has the signal from the discriminator, and it helps him to learn. He might see that some of the images he produced are better at cheating the discriminator, and some of them are worse. So he might modify its strategy to fool the discriminators. So it's actually a game between discriminator and generator where each one of them is trying to fool the other. Now, going forward, what is interesting is that if we provide additional information to both of these networks, so let's say we were training on images of cats and dogs, and we were also giving a label whether this real image is of cat or a dog, and also if this synthetic image is of cat and dog, then in the end, our generator will be able to generate images conditioned on the label. And in this way, we can control the generative process more. So now, after training such a model, we can, for example, generate images conditioned on color or category, or a lot of different things that are actually only limited to the labels that we have in our data set. Now, going forward, we imply a text input as well as triplet loss to be able to generate something even better. So in our case, as you recall, we are interested in adding text in natural language. So we want that to use as an input to GAN model, as well as already existing real image from the user. And then as an output, we want to have a synthetic image that was modified according to this free language query. Then we will, of course, search this synthetic image in the product database in order to present the user with some final images. Now, here is the architecture of our model that we built. And as you can see, it's a bit more complicated than the previous vanilla and conditional GANs. And the difference is that the input to the generator is not some random noise, but it is already an image and a text. So both of those inputs are first transferred through image encoder and text encoder to have two vectors. And those two vectors are fed to the network. And finally, we're also using triplet loss to be able to train our network in such a way that synthetic images are close to the actual target images that we were looking for in our database. Now, here are some results of how our model is working in practice. And you can see an image on the left that was fed as an input from the user, together with his text query, which mentioned that he wants a dark-colored, long-sleeve, button-down shirt on a model like similar to these with similar body type. The target image, the second image, is his intention that he wanted to retrieve from the database. The third image is a synthetic image. It is nothing that existed in our database before, but then we used that to retrieve the most similar items from the database. Similarly, in the next example, you can see that being presented with totally different image that was not being worn on a model, but it was just presented on a white background and given additional text query, our model was able to produce the third image, which is a generated one. And by using this image, we just retrieved the most similar results from the database and presented them to the user. Another example, we used the text query to prolong the sleeves and also to add a flower pattern on the blouse being worn by female model. Now, what is interesting, after generating such model, we are able to continuously interpolate in the generated embedding space. So we are able not only to generate those particular items, but to go smoothly from one to the other. And such features as color are presented smoothly in the generated items. So here you can see on the left the image input that was fed to the model together with text query, which ranges from blue to yellow. And when we interpolate between those two text queries, which are not continuous values, so we were not using text like it's a little bit more yellow, even more green, even more blue, but we just continuously interpolated and generated 8 examples between those two text vectors. We can see for other examples how smoothly we can interpolate in the generated embedding space and to change the features and attributes of the generated items by just a bit in our desired directions. So it gives more freedom over the generated items, and it allows users to find the fine-grained details in the product that they are looking for. Now, a takeaway from this part would be that combining different modalities, such as images and text, is actually something that provides a lot of value to the users and helps them navigate the databases in a more efficient manner. Going forward to the second part of my talk, I will present some of the creative applications of GANs and art and how to navigate beyond the limitations of how the GANs were actually thought to work and how can you use them for so many different applications. The first project that I did was focused on generated architectural design, and I wanted to see how the model will be able to generalize on the images of the architecture of Warsaw buildings. So in order to train the model, I collected more than 2,000 digital images of Warsaw buildings that I shot for a couple of weeks in the streets of Warsaw. They were all cropped to square images, and the same pre-processing was applied there with the similar colors and contrast, and they were sized to the same size. Here is a sample of the training data that was used. So as you can see, they were taken from a lot of different viewpoints, and some of the colors were different, but the stylistical similarity was preserved, and they contained a lot of different architectural styles, such as common buildings, churches, newer buildings, old town buildings. And after training these generative adversarial networks for 1,000 epochs, so depending on the graphic card that you might have, it might be a couple of hours or even several days, the model was able to produce results that were not before seen in any of the training data. And they provided some interesting insights into the architectural style of the Warsaw buildings. None of those buildings exist, but they provide some interesting ideas. And what is interesting, you can even interpolate, again, continuously between different buildings and see the deformations from one style to the other, which looks like some mad architect's dream. If you want to see the results of those video interpolations, scan this QR code for more results. As in the presentation, I can only show you the still images. Now, what is interesting about this is that by knowing the training data beforehand, I was actually able to see any ways in which generative adversarial networks were trying to generalize. So it was very quick to capture the more often viewpoints that I shot, as well as it was quick to learn some of the perspective tricks. So as you can see, it liked several of the viewpoints, and it presented most of the images using those viewpoints. And also it was quick to learn some architectural elements like columns, windows, reflections in the window. I even realized that some of my images contained tram elements, and they were also presented in the trained data. So this gave me a takeaway that actually you have to be very careful about what you have in your training data in order to train efficient generative adversarial networks. Now, for the second project that I trained using generative adversarial networks was abstract art creation. And here I collected 2,000 images of common objects in red lighting, and I tried to actually go into some abstract forms and shapes, as I was interested in what kind of different shapes the network will be able to produce. And I wanted to go beyond our common objects that we see in our lives and our common understanding of forms and lighting, and to see how well the network will generalize and what interesting results it can produce. So here again, I shot more than 2,000 images, as it is usually the smallest amount of the images that you can use to produce some good-looking results. And here is a snapshot of the actual images that were used for training. So as you can see, they were quite abstract. Some of them contain wires, some of them contain some bottles, glasses, some metal objects. So a lot of different things that you can find in any regular household. After training, it produced particularly interesting results, as the shapes were not really any of the objects that I shot. I didn't see any of the exact same objects, but what is interesting is that some of the features were preserved, and some of the objects even looked like a combination of, let's say, fork and a glass. So it was really interesting to see what strange abstract forms from the stillness of common objects the generative adversarial network can produce. And if you want to see some more of the results, here again, you can scan the QR code to see the gallery. And you can also see some interpolated videos of how those objects are actually moving in the interpolated space. Now, from training many GAN models, I actually have realized a couple of things, and with the experience in training more models, I can see that there are some of the things that get repeated, and some of the points are quite important when to have in mind when training such a network. So what is fortunate is that with the introduction of such methods as StyleGAN2 ADA, which was introduced by NVIDIA last year in the autumn, you can even train good quality results with as few as 2,000 images. If a couple of years ago, you needed 40,000 of images to produce some realistically looking results, nowadays, even 2,000 images is enough to produce some nice outputs. However, you have to bear in mind that the less ambiguity you have in your training data, the more high quality results it will produce. If you were to train network on images that were shot with different cameras and different lighting conditions, a lot of different use cases such as portrait, architecture, products, panels, cars, it will be very difficult for a machine learning model to generalize. Of course, if you were to collect millions of images, it would be able to capture all of those different categories that you have in your data. However, if you just have a couple of thousand of them, you need to restrict yourself to one of the domains. So the less ambiguity, the less different camera settings, the less different viewpoints, the less ambiguity, the higher quality. Now, also, you have to be really careful about what you have in your data. So networks, generative adversarial networks, are perfect in generalizing. It is also something that you have to bear in mind, that they will never create something totally new and totally different. It just seems to us humans that those things have never existed before. But what the network does, it generalizes from the things it sees. So it might notice some of the characteristics in your data that you have never noticed. It might notice some noise, it might notice some errors, and it will also work on creating them. So you have to be really careful about what you put into the data, as if you're just training regular machine learning models, they would ignore the errors and they would ignore the outliers. However, GANs, they are often just recreating them as they see something in the data that is easy to replicate, and they will just use that as a cheating method against the discriminator. Now, GANs are very good at capturing patterns, structures, textures. They all produce the results that look realistic on the first-hand side, but it is also important to note that GANs are still not good at capturing the logic behind the data. So for example, if you had images that contained a lot of text, what such GAN would do, it would create images with fonts or some text-like looking patterns. But you should not expect that those patterns would be legible or that they some letter-like looking shapes. So if you wanted to train, if you wanted to add some more logic, even having more data, or adding some additional information to your GAN structure would be really beneficial. Now, the last but not least, AI is still a tool, and GANs in particular, they are not using their imagination, they are not extrapolating to create new results, but they're just a great tool that you can use to produce something unexpected, but also something that is generalized from the data that you have. Now, the last short usage that is actually very trendy right now. And what happened is that GANs, as well as a lot of other different digital creations, are used for on the blockchain for the NFT art. And in the recent couple of months, we have seen a lot of growth in the area of NFTs. Now, even though the generative art has already been sold in worldwide galleries, and in 2018 it was sold for $400,000, recently a work of digital artists sold for even $69 million. And this whole trending hype that we have seen in social media in the recent couple of months is actually a solution to some of the problems that the digital art had, and some of the artists are really looking forward to the wider introduction of NFTs. And a lot of people are saying that this will be like next blockchain or next Bitcoin. And it's really interesting where we're going to go with that, as right now it's just the beginning. And yeah, so for those of you who don't know yet what is actually NFT, it's a non-fungible token that can be used on different blockchains. And the most popular one is Ethereum blockchain. And for art or for some other different items, it works as an originality certificate. So you can imagine the problem that digital art had and all of the digital creations when you could easily copy them or just download the JPEG to your computer, and it was hard to say whoever has the original. This is the solution to this problem, because the NFTs provide a uniqueness certificate, and now only one person is able to hold that authentication, and many other people can have copies. So it provides ownership of the original item. And also a lot of the people with the current rise, which is only just accelerating of the NFT space, are also seeing it as an investment opportunity in the crypto space. So it is really interesting. It looks like just the beginning of this NFT wave, and it's growing so much that I'm really curious to see where is it going to be in a couple of months. Right now, NFT marketplaces such as OpenSea, Rarible, Super Rare, and others are seeing incredible growth in their user bases, and many of the collectors or brands such as Adidas, Nike, even Netflix are doing their first steps into the NFT world. So if you're a company, if you're producing any products, it also might be something of an interest to you to perhaps mint your NFT, or to see if there are any possibilities on how you can use on all this hype and find new avenues for your user base. Okay, so this is actually everything from my side. So if you guys have any questions, type them in on the chat, and I will answer them. And if you're interested in knowing more, you can also reach out to me either here or by email. On the social media, you can follow me for more information on the AI art, NFTs. And if you're interested in any of the tips on how can you train a generative adversarial network on your data, or how can you use any of the ideas that I mentioned here, feel free to reach out to me. And that's all from my side. Thank you.